Welcome to BTech BDC. Today we are going to discuss some type of problems that are repeatedly asking on GATE exams on control systems. Let us start. First question, given the transfer function g of s is equal to 121 divided by s square plus 13.2s plus 121. Which of the following characteristics does it have? First option, overdamped and settling time equal to 1.1 second. Second option, undamped and settling time equal to zero point 0.6 seconds. Third option, critically damped and settling time equal to 0.8 seconds. And last option is underdamped and settling time equal to 0.707 seconds. Okay, here the given g of s is equal to 121 divided by s square plus 13.2s plus 121. Okay. From the standard characteristic equation formula, from the standard characteristics equation formula of a transfer function, it is s square plus 2 zeta omega ns plus omega square n. Here, zeta is the damping ratio and omega n is the natural frequency of oscillations. Okay, by comparing these two equations, from this g of s, we know that the denominator is the characteristic equation. So, we can compare these two equations. That is s square plus 2 zeta omega ns plus omega square n is the standard characteristic equation. This will be compared to s square plus 13.2 s plus 121, which is the characteristic equation from g of s. So, from this two equations, we get omega square n is equal to 121. That is omega n is equal to root of 121, which is equal to 11 radians per second. Don't forget to write the unit, 11 radians per second. Okay. Then, we all know that the systems are classified into 4 types based on the damping ratio. Based on the value of zeta or damping ratio, the systems are classified into 4 types. First is undamped. For an undamped system, the value of zeta will be less than 0. Second type is underdamped system. For an underdamped system, the value of zeta lies between 0 and 1. That is 0 less than zeta less than 1. And third type is critically damped system. Critically damped system. For a critically damped system, the value of zeta is equal to 1. And the last type is overdamped system. Overdamped system. For an overdamped system, the value of zeta will be greater than 1. These are the type of system classifications based on the value of damping ratio. So, the next step is we have to find the value of damping ratio or zeta to determine whether the system is undamped, underdamped, critically damped or overdamped. For this, we have to compare the value of the coefficient of S. This is the coefficient of S. That means 2 zeta omega n is equal to 13.2. We know that the value of omega n is equal to 11 into zeta is equal to 13.2. That is means damping ratio zeta is equal to 13.2 divided by 22, which is equal to 0.6. The value of zeta is equal to 0.6. That means the damping ratio is less than 1 but greater than 0. So, we can identify the system as underdamped, right? Underdamped system. Okay. Then you have to find what is the settling time. Here, to find the settling time, there is no tolerance is given. So, we have to consider there is 2% tolerance. 2% tolerance. The equation for finding the settling time T of S, sorry, Ts is equal to 4 by theta omega n. So for 2% tolerance, Ts is equal to 4 divided by the value of damping ratio is 0.6 into omega n is equal to 11, which is equal to zero point 0.6 seconds. So this is the correct value of settling time. Okay. Now I have to find what is the value of for 5% tolerance. This is the standard tolerance ratio. So for 5% tolerance, Ts is equal to 3 by theta omega n. That is 3 divided by theta is equal to 0.6 into omega n is equal to 11. So 3 divided by 0.6 into 11 is equal to 0.45 seconds. So here the system is underdamped, that we all know. But the settling time is equal to 0.707 is not the correct option. So these are wrong. The correct answer is underdamped plus 0.6 seconds settling time. This is the correct answer. Then the next question will be discussed in the next video.